Our University of Vermont Capstone Senior Design project was to propose a retrofit design for an overturning retaining wall on Butternut Road in Williston, Vermont. Our team consisted of Genevieve Anthony, Christopher Gavitt, Matthew Lawliss, and Justin Parker. Butternut Road, as indicated by the red flag in the lower right corner of your screen, is a gravel road located off Route 2A, about 3 miles south of Interstate 89 in Williston. These photos show the current conditions of the wall. The first photo shows a section of the wall which is most severely leaning. At one point, the wall is leaning as much as 23.6 degrees. The next few photos show how the wall was constructed improperly. When originally constructed, the keys were not adjoined properly, and here you can see the seams on the wall were not staggered, causing the wall to act like 18 separate walls instead of one 108-foot wall. Soil is eroding from under the retaining wall, as can be seen in this photo, and some of the individual blocks are deteriorating, causing debris to fall in the unnamed tributary which runs along the retaining wall. The guardrail which borders the wall is also in need of replacement. As you can see here, the rail has been struck by a vehicle, causing the buckling of some of the posts. The wall is beginning to overturn. This is due in part to the high water table behind the wall, which creates larger active pressures. Another reason for the overturning of the wall is that the soil behind the wall has been washed out and subsequently has been refilled and recompacted. The preliminary work included an initial site survey in order to input the points into AutoCAD. Stream cross-sections were also surveyed for inputting in HEC-RAS. These are the results from a HEC-RAS model and a HydroCAD model which was created. Shown are the results from a standard flow as well as 1, 5, 10, and 100-year storm events. Next, boreholes were drilled using a hand auger. Here you can see the high water table which was mentioned earlier. The collected samples were analyzed through sieve and hydrometer tests to determine grain size distribution of the soil. Using this data, it was determined that the current soil was not adequate backfill and therefore could not be reused, and a more permeable backfill must be introduced. Water samples were collected and analyzed to gauge the stream health. pH, turbidity, and dissolved oxygen concentration were all measured. After collecting all field data, an initial design alternative was created. This design is called a dead man design due to the concrete blocks used as anchor weights in the soil. This design is effective because for the wall to slide or overturn, it would need to overcome the soil pressure on the anchor blocks. Another highlight in this design is a 6-inch curtain drain buried in the 1-inch cleanstone. These aspects are used to lower the water table and relieve active pressures from the retaining wall. The final key aspect of the design is poured concrete base, which will be poured on the bedrock. This will give the wall a sturdy, even base which will not erode. The group was in constant contact with our community partner Lisa Sheldra, the Assistant Director of Public Works of the town of Williston. After coming up with our initial design alternatives, the team had a sit-down conversation with Ms. Sheldra and Bruce Hort, the Director of Public Works, to discuss these designs. They raised several concerns with the layout and expressed an interest to minimize the cost of the final alternative. After the meeting, the team conducted further geotechnical calculations and made several alterations to our design. Our final design is shown here. As you can see, the dead man blocks were removed and the upper block was changed from a 4-foot by 4-foot by 2-foot block to a recycled 2-foot by 6-foot by 2-foot block. These alterations were made in response to the updated geotechnical calculations and the fact that the dead man design was significantly over-designed. Also incorporated in this design, to prevent sliding, an industrial adhesive mastic was designed in. The new guardrail will be buried to a depth of just over 2 feet and therefore will require extra posts to anchor and provide support for the rail. Behind the wall will be a geotextile fabric which surrounds the 1-inch cleanstone and the curtain drain. This fabric will prevent clogging of both the pipe and the porous cleanstone. Behind that will be the road base and gravel road topping for the driving surface. Our group would like to give a special thanks to Lisa Sheldra and Bruce Hoare of the Town of Williston Public Works Department, and our instructors Dr. Mandar DeWolker and Dr. Nancy Hayden.